Today we're going to find the sine, cosine, and tangent of double angles. That would mean twice the angle that's currently given to you. Most of the use of this is an application because it will allow you to find the derivative and antiderivative of certain functions with much better ease. And it is also helpful in solving trigonometric equations. So we're going to begin by finding the value of tan 2 theta. That means I want the tangent value of the angle that's twice as big as this given angle. So what I need to do first is look at my formula. And I look at my formula, and that's easy enough. I just substitute in. I need to find the tangent of the just plain u, not twice u. So the tangent of theta equals opposite over adjacent 1/4. Then I simply plug into my formula. The tangent of 2 theta will equal twice the tangent over 1 minus the tangent squared. Now it's just some math. This becomes 2/4, which reduces to 1/2, over 1 minus 1/16. So then I get, following along down here, I get 1/2 over 15/16. That's more easily written as 1/2 divided by 15/16, which means you multiply it by the reciprocal and you end up with 8/15. And you could have reduced after 16/30 as well. 16/30 is 8/15. So then this is the value of tan 2 theta. So if I was to ask you to find the solutions on this interval, here's an application. I cannot solve this trigonometric equation as is. The reason I cannot is this is a 2x and this is x. In order to solve a trigonometric equation as we have in the past, those angles need to be the same. So I need to make them the same. I'm going to use my double angle formula because I can rewrite the sine of 2x using just x's, which will make it easier to solve. So I get the sine 2 sine x cosine x plus cosine x equals 0. I substitute it in. So this is one of the applications of double angle formulas. Then I can solve as usual. 2 sine plus 1 equals 0. I set each factor equal to 0. And then I solve. Sine of x equals -1/2 minus 1 divided by 2. I need to find those values on my unit circle and make sure that I'm in this interval. So cosine is 0 here and here. So my solutions are pi halves, 3 pi halves. The sine is -1/2 here and here. So my other solutions are 7 pi over 6 and 11 pi over 6. And those would be my solutions. Now, I can rewrite using double angles. The reason why this is helpful is in finding the derivatives. So, you don't know how to find the derivative of this, do you? Well, let's take a look. This looks most like this formula. So, if I factor out a 3, the GCF, I am left with this. This is a double angle. So this is 3 cosine of 2x. You can find the derivative of the cosine 2x. The derivative of cosine is negative sine. And you multiply the coefficients out front. So I get -6 sine 2x. So this would be rewriting it. This would be the application. I can now find the derivative, whereas I could not at this step. So if I want to find the exact values, this reminds me a lot of this kind of problem back here. What is the exact value of the tan of 2 theta? Except now I'm going to find the sine, cosine, and tangent. It kind of gives me some information. It tells me what quadrant I am in because it's between pi halves and pi. It's in this quadrant. I can use my information to label my triangle. Because it's to the left, it's -2 here. This is a 3. And then I can use Pythag to solve for my opposite side. 4 plus b squared equals 9. B squared equals 5. B equals plus or minus root 5. But it's a length, so it's going up, so it's root 5. So, knowing that, in order to find the sine of 2 theta, I need to plug into my formula. So the sine of 2 theta, what's that going to equal? It's going to equal twice the sine value. The sine value is root 5 over 3. The cosine value, which is negative 2 over 3. Multiply my numerators, I get negative 4 root 5. Denominator, 9. So this is the sine of 2u. Now I'm going to continue because I'm going to do the cosine of 2u. So the cosine of 2u is going to be, pick your formula. I'm going to do, let's do 2 cosine squared u minus 1. So cosine squared, cosine is negative 2/3. I didn't want to deal with radicals. Squared minus 1. So I get 2 times 4 ninths minus 1. 8 ninths minus 1 is negative 1/9. So the cosine value of twice this angle is going to be negative 1/9. Now I'm going to do the tangent. The tangent happens to be just one singular formula. So the tangent of 2u is going to be twice the tangent value, which is opposite over adjacent, over 1 minus the tangent value squared, which gives me 2 root 5 over negative 2 over 1 minus 5/4. Well, that gives me, if I keep going, let's go over here. Gives me 2 root 5 over negative 2 divided by, this becomes 4/4. So divided by negative 1/4. That means you multiply by the reciprocal. And you get 8 root 2 over 2. You reduce. 4 root 2 would be the tangent value of twice that angle. So now you give this one a try. All right, so let's do it. Cotangent, quadrant. Quadrant's going to be between these two. Here I am. Cotangent is 4. That means the tangent is negative 1 over 4 because it's a reciprocal. So this is 1 and this is negative 4 because my sine is my height of my Ferris wheel. So now I can use Pythag. 1 squared plus negative 4 squared equals c squared. 1 plus 16 equals c squared. Square root of 17 will be c. Now, to find the sine, I plug in. So I'm going to make my pen thinner so I can fit it all in here. The sine of 2u is going to be 2 times the sine value, which is negative 4 over root 17, times the cosine value, which is 1 over root 17. Doing my math, I get negative 8 over 17. Done. Cosine 2u. I can pick my formula. I'm going to do twice cosine squared, because I like that one. Twice cosine is 1 over root 17 squared minus 1. When I do that out, I get 2 times 1 over 17 minus 1. 2 17ths minus 1, which is negative 15 17ths. Then the tangent of 2u will be, if you look down here in the formula, twice the tangent. And the tangent happens to be, sorry, I got to extend my screen here so you can see. The tangent is opposite over hypotenuse, 4 over 1, divided by 1 minus the tangent squared. So that gives me negative 8 over 1 minus 16, which is negative 8 over negative 15, which is 8/15. hope you got it right. And that is it for now. Next will be half angles.